Hello and welcome to the John Park's Workshop. Here we are. It's Adafruit West. I'm John Park, and you're right here in my workshop. Welcome. We have all kinds of great, exciting, fun stuff to take a look at today, to talk about, to play with, to build. And so why don't we just get started? Let's see, first of all, I would love to check in with people. If you are joining us in YouTube, hello, I can see you over in the chat there, Matambale and Thomas Veach. And otherwise, if you're tuning in somewhere else, such as Twitch or Periscope, unfortunately Facebook doesn't seem to be launching right now, then maybe you're over in the Discord chat. If not, head over to the Adafruit Discord. That is at adafru.it/discord. That's our URL shortener, adafru.it. We're not Italian, but we got that .it because it spells out fruit. And actually, I'm half Italian, but /Discord, that'll get you over to the Discord chat, and that's where lots of good conversation is happening. And hello, Wolf220 and C. Grover, Mr. Certainly, Dan Mitchell, hello. And let's see. For some reason, we don't seem to be launched on Facebook. Very sorry, Facebook. I'll check in periodically to see if we can hit launch on that, but maybe something's up. I don't know. I guess a lot of people are using Facebook. And good. Okay, so we're live on YouTube as well. Terrific. Thank you for checking in for me. That means I can pause my little YouTube window over there so I won't see a 10-second mirror version of myself. So let's see, what have we got? First of all, I wanted to mention our jobs board. If you're looking for some work, and I know people have all kinds of different and rapidly changing work situations right now. If you are looking for work, head on over to the Adafruit job board at jobs.adafruit.com, and you can take a look for some contract work, freelance work, possibly some full-time positions as well. There's a bunch of different types of jobs listed up here. And you can also, if you go to jobs.adafruit.com, all you need is a Adafruit login, same one that you use to use the store. It's free, and you can search jobs, you can check available for hire, and you can also, if you're signed in, you can submit your resume and other info so that people can find you if they're looking for this available for hire section here. So that's jobs.adafruit.com. I encourage you to go check it out. Let's see. The next thing I actually wanted to talk about is the Make Code newsletter. So we just launched this month's, the April edition of the Make Code newsletter. It landed in about 1,300 people's inboxes, so thank you for subscribing. If you want to subscribe, just head to adafruitdaily.com. You can see, whoops, why did I do that? Let me just click on adafruitdaily.com. I'll come back to this. You can go there and sign up for any of the Adafruit newsletters. You'll just hit a checkbox next to the one you want to subscribe to, such as Make Code. Type in your email address, hit sign up, and it'll come to you every month if it's the Adafruit Make Code newsletter. If it's Python on hardware, that one comes out weekly, and there's different cadence for different newsletters. But I wanted to run through a little bit for you about this month's newsletter. We have, at the top, we've linked to a bunch of great streaming resources that the Microsoft Make Code team is doing. These are resources for students, educators, people dealing with virtual classrooms or study at home. And the Make Code team has been taking turns doing hour-ish long live streams where they're doing coding in all of the different Make Code platforms. So that can include Make Code for Minecraft educational version, Lego, Make Code for Lego, as well as some of the ones you're more familiar with on this show, which are Make Code for the Microbit, for Circle Playground Express, and Make Code Arcade. Then we also linked to, here's an example of Jacqueline of the Make Code team with her kids, I presume, doing the kitchen, Make Code in the Kitchen series. We also have, if we scroll down, some other people streaming, like our friend Nina. Hello, Nina, there. She did, I think, at least one stream doing Circuit Playground Express Make Code. I usually pick out a MakeCode Minute and a MakeCode Arcade Game of the Week to highlight there, as well as some news from around the web, such as the Micromag, which is a microbit featuring microbit focused magazine. You can go check that out at Micromag. There's a guide we linked to on creating custom boards for MakeCode, so you can bring your own hardware in to play. There's a pretty cool tip from the Kytronic University on storing multiple values and text in a single variable. There was a Lego education hand sanitizer pump, so a hands-free, motor-driven pump that will allow you to get some soap or some sanitizer on your hand, just like you're at a fancy bathroom. And maybe this one will work better than that one you usually find in the bathroom that doesn't notice you're there. And let's see, I'll scroll through some of these. You can check them out yourself, but we also have, I will point out a couple of guides that came out, including Aaron's excellent game timer guide and the Circuit Playground Express hand wash timer guide. There are some new extensions featured, some new hardware to go check out. I'm always amazed when I go searching around that there's all kinds of new MakeCode compliant hardware being built as add-ons for the different boards. And then we have a bunch of resources for educators down at the bottom, links, and you can check this out if you just go to the Adafruit Daily and sign up for the MakeCode newsletter. Whew! All right, that was a lot. Let's see, what do we want to do next? Oh, I want to let you know that once again today I'll be hosting a very special edition, the second edition in the week of Show and Tell. We had Show and Tell for an hour last night before Ask an Engineer, and then I'll be hosting about 40 minutes after this show ends, or half hour or so after this show ends. So that's going to be 5:30 p.m. Eastern Time, 2:30 p.m. Pacific Time. And we have a blog post up, a reminder post up on the Adafruit blog. You can go check it out. And if you're interested, I would love to have some people come on the show, show some cool things that you're working on, or some stuff that you've built already, or some parts that you have laying around that you're thinking about building something with. And I'll be dropping a link to the StreamYard. All you need is your web browser, by the way, just a web browser, webcam of some kind, and maybe some earbuds with the microphone in it. That works pretty well so we don't get echoes. But you don't need to download any particular software. You just have to log into the link I'll send. Sometimes you have to give permission to your browser. Your operating system may want to get some explicit permission so that the browser can use the camera and the mic, do screen capture and that sort of thing. So that's going to be the Show and Tell, and that'll be up at 2:30 p.m. Pacific Time, 5:30 p.m. Eastern Time. So come check it out, please. And hey, I've got, let me go check this window. Nope, still no, Facebook really doesn't want to play today. So, oh well. But I do have for you a product of the week. So my product of the week this week is ye old NeoPixel stick. So I wanted to pick something that I find to be very cool, very fun, very useful, and available at DigiKey. And as you may know, right now, Adafruit is only really dealing with COVID-19 related orders. So if you want to get some regular Adafruit stuff and you're not using it in any medical or PPE devices, then head over to DigiKey. In fact, let me show you their page. There's the Adafruit page for this device. You can learn about it here. There is the DigiKey page. I checked. They have 1,506 of them in stock. It's the same price, and you might be getting other DigiKey stuff as well. They are shipping, so head on over there if you want to check out some good Adafruit stuff that you can buy. This one, let me show you my overhead camera. One of the reasons I really like this, let's pop that off of there for a second, is you can test things really easily with this. You can make small little bar graph displays for different projects you're working on. It's very easy to deal with. I've just soldered on some header pins onto the back here and then plugged it into a female header I put onto a feather board and ran power, ground, and digital in to, I think it was pin D5 here. And you can stack them as well. You'll see here I've actually got a second one that I plugged in there into the first one. So these send data line in and then data line out, and they have matching pins, so it's very easy to wire those together. You can solder them permanently, or you can use some little connectors like I did here. And so that is my product pick of the week. It's the ye old NeoPixel stick. We have them, I say ye old because I think these have been around for a while. But we have these in a couple of different varieties. This is the straight up RGB. There's also RGBW that have a fourth diode in there which does white light, and I think that comes in cool and warm flavors. So I think there's like 3 flavors of these. This is the sort of regular old one. So go check that out, would you? All right. Let's see. I think I'm going to skip Gear Report this week because I have so much other stuff that I want to show you. And in fact, the thing I showed in last week's Gear Report is featured in the project that we're going to build this week. So it's a pseudo Gear Report thing, but I don't have anything new or recently found that's old from my workshop to show today. So what that means is it's time for the Make Code Minute. All right, so let me get set up here, and I can throw black background back there. So what I wanted to show today in the Make Code Minute is a brand new extension that you can add to Make Code Arcade that is called the Sprite Data extension. And there is a blog post or a forum post in forum.makecode.com that Pelly, a member of the Microsoft Make Code team, posted announcing this just a little less than a week ago. And he calls it here the Arcade Sprite Data extension, and there's a link to the GitHub. And there's little instructions here on how to add it. So one thing you may not know is in Make Code and Make Code Arcade, there's this little extensions section, which usually lists a few extensions that you can add. But there are also extensions that haven't been added officially here, which you can get by typing in a URL. And so that's what I did already. You won't see it come in a second time, but that URL is listed right here. It's arcade-sprite-data inside of the Microsoft GitHub. And by adding that, I got extra blocks in my sprites dropdown. So you can see here this data section says set item data and then a string to number, or change item data by number, as well as set item data, and this one stays a string. So let me show you how I'm using these and why I think they're cool. If I expand my little scene here and move my character, which is this little computer, to run into this ice cream cone, I'm pretending the ice cream cone is a non-player character, an NPC. And when I bump into this ice cream cone, I get a little dialogue that says, Ice Cream Sally. So I get the name of my character here. And you'll notice that my points in the corner there raised to 5. And now when I go meet this pizza, it's going to say, Pizza Joe. And we've raised another 3 points. And you'll see at this point, running into them again doesn't do anything. I have a little reset I can use, but it's essentially saying I've gotten a meeting with these characters and something has transferred to me. So you can see how you would be able to use that in a game for some interesting gameplay. And now what I wanted to show is how this works. When I create my characters here, which are this slice of pizza that I called NPC1, I set the usual things like an image from the gallery and a position, and then I'm using one of these data blocks to give a few pieces of data. One is this state. Have I met it yet? And initially, no, I haven't met it. Second is I've given it a name, which is Pizza Joe, and it's a string. And then third, I've given it these points values, which is 3 in the case of pizza, and with Ice Cream Sally, it is 5. So then when I have a collision or an overlap during the game between my player sprite, here I say on sprite of kind player overlaps other sprite of kind NPC, non-player character, these things happen. First, I check that data that's on the character. So we're reading the character's actual data that it's carrying around to see if we've met before. And if we haven't, then we go and display that string of their name, as well as change the points, and then flip that bit so that we don't run into them over and over again. So I find this to be really cool, really helpful. It's a way to have a Sprite carry around some data with it without building a whole bunch of extra blocks. We just get these very convenient little blocks, and the data sticks around with the character or sprite wherever they go. And so that is your Make Code Minute. Is it me, or is that really, really cool? I'm going to check in on Discord. What do we think, Discord? Do we have people who are working on these games? Anyone who's ever worked on a Make Code arcade game, I think you'll find that they keep adding really great features that clearly show that the team members are making games. I know that they're making games with these, and they're also working with users. And so they're listening to these requests, or they have their own things come up where they say, hey, how handy would it be to add this? And I've noticed, I think, during the self-isolation here, some of the team members have been on a tear adding really cool extensions, particularly Peli. So thank you for that. I'm really looking forward to checking those out. Yeah, you could. Dan Mitchell in Discord says you could do a role-playing game, an RPG, in Make Code Arcade for sure. I think this really simplifies that. It's a great feature for that type of game. All right, so hey, guess what? Speaking of games, it's time for my Make Code Arcade Game of the Week. So let's switch back over here to my Chrome window. And my Make Code Arcade game pick of the week is called Charred Earth. And Charred Earth by Jacob C. is a whole lot like a 90s game called Scorched Earth. And I think I had one on my Apple IIe that was called Salvo. And the idea of this is it's a trajectory-based tank or artillery game where you're finding an enemy, changing the elevation of your turret, choosing how much power to put behind your projectile, and then lobbing it through the air to try to land on your enemy. So enough talk, let's check it out. Here is the game. I'll go full screen here. And first thing you'll notice is initially it's turn-based, so there's player 1 and player 2, human-controlled. First we have these arrows that indicate that you can move the camera around. So this is used to figure out where the enemy is. I suspect the enemy's over on the right. So I'm going to toggle over until I find them. Are you on the other side of this hill? I'm going to guess. Holy cow, this enemy is far away. I'm going to restart actually so that we can get a different start position. I think it's randomly chosen each time. Where are you? Nope, it's not that way. Okay, so I ran out of camera. So let's head the other way. Aha! Oh, this is a good, easy one. We're really close to each other. I won't just aim straight at the guy, though. So what happens is after you have determined where the enemy is, you hit the A button to shoot, and I think it's the B button to toggle between moving. Oh, what did I do? That was weird. Let me start this over. Okay. This will make it easier for the video to actually have a clean start. So thanks for your patience. Okay, so when we start, we can move this camera around using our D-pad controls to try to find the enemy. Boy, this is a sneaky enemy. Where are you? Maybe off to the left. And once we locate them, we're going to switch out of camera mode and instead switch into turret mode. So I believe that's the B key, once I get back to my character here. And now you'll see that as I move the arrow keys, I'm getting a different elevation for the gun turret. So I'm going to pick an angle that I think might reach. And then the power right now is set to 100, and you can increase that with the up arrow key. So I'm going to set this, say, to around 200 or so. And now when I press the space bar or A, it's going to fire a projectile. All right, not bad. So what I'm going to do when it's my turn again, so I'll try it from this guy's perspective. I'll probably just try the same power but a higher angle. Okay, he way overshot. So let's now move to the right just a little with the arrow key. And this is kind of cool. If I want, I can switch back to camera mode to double check where that enemy is, and switch back into firing mode with the E key, which is the B button on the console. And I'll fire again. And, oh, just barely overshot. Okay, so this guy is my, you know, when you play a two-player game against yourself, you're really rooting for someone. So let's adjust it just a little more. Let's see if we can hit. Oh, I'm just shy of it. Okay, so you can see how that game goes, and there are a lot of really great things in this, including a custom extension for doing text as images. One feature that I wanted you to look at, or I wanted to talk about in particular, is this use of the camera essentially as a character. So normally we're used to controlling a sprite, but when we are in this mode of moving the camera, this function is called here, and it allows us to center the camera by setting the camera's X position and Y positions based on, and then it's doing a little math to center it by doing half of the screen width and half of the screen height, and then as you press the arrow keys, you're accumulating X change and Y change offsets. So I thought that was a really nice way to give the player control over the camera, and then we can switch modes back to controlling the turret. And so that is the very difficult, but also pretty fun, and you know, it could take some time, but a lot of us have time on our hands. Charred Earth. And so Charred Earth 1.0 by Jacob C. is my MakeCode Arcade game pick of the week. All right, so let's check in with the Discord and the YouTube chat. Hi, over there in YouTube land. Hey, Brent, welcome. Brent, our very own Brent Rubel from Adafruit is checking in. Hello. Hey, Jay Dosher, nice to see you. Raspberry Pi Dude 314, Marwan Naja, hello, hello. And how's it going over here in Discord? Let's check in. It's rainy here today in Southern California, so we got that going on, which is probably a good thing. So I hear Power Glove talk. Okay, let's jump into some Power Glove stuff. Wolf220 asks, what category are the camera blocks in? Let's jump back in for a second. If I pop open my Chrome window, you'll see under Scene, I think it's under Scene, down at the bottom there is camera centering, camera following sprite, which you can use with, like, when characters walking off screen, the camera will stay centered on them. And then these coordinate points for left and top of the camera, as well as a camera shake, which is a fun effect you can use. I think it actually might happen in this game when you hit. I've hit one tank once earlier today. So I just found this game today. All right. Anything else in Discord? I keep losing my Discord window. Where'd you go? There you are. Raining in Massachusetts. Hey, Blitz City DIY. All right. Oh, I'm glad to hear you don't have snow, I suppose. Dan Mitchell's got snow in southern Ontario earlier this morning. Hey, Charles Bernaford, Southeast PA. Yeah, it's not too cold here for sure, so I won't complain. All right, so let's get to the project of the week. So I have, let's see, how do I want to show you? Let's pop over to the down shooter on the camera bench here for a minute. And what I've got this week is I've had this Nintendo Power Glove for a while, and I've shown it on here before, and I've been looking for the right project to use it for. If you're not familiar with the Power Glove, mine's semi-taken apart at the moment. There's the Power Glove. So this was a Nintendo controller for a Nintendo Entertainment System, and way ahead of its time. It essentially tried to track your hand in 3D space using a pair of ultrasonic emitters and a set of ultrasonic listening, like microphones essentially, that would be on a frame around your TV. And so as you moved your hand, there was some triangulation or something like that. I know I always get that word. It's a different word than that. I'm sure Jay Dosher can tell me. But something like triangulation would allow it to sense where the glove was in space. It had 4 flex sensors. These are variable resistors that are in the these 3 fingers and the thumb. So as you bend them, those would register as analog controls. And then it had a bunch of buttons and a D-pad for starting games and menu selects and things like that built onto this. So what I did originally is I desoldered the plug that goes off to the console. It's a regular sort of Nintendo DIN plug. So I've taken that off because I want to use this wirelessly. And then I've taken off some of the housing here. This is a back panel. Let me move this out of the way here, but I'm going to demo something on that iPad, so I'm just going to move that slightly. So what I have removed are a little wrist rest that's here. This is a strap that allows you to strap it around your wrist, and then you put your hand inside of here. So I've pulled this off initially so I could get at the screws that hold the electronics on the wrist. And there's actually a circuit board here, and there's also a circuit board up in what's sometimes called the palm circuit board. It's on the back of the hand. What is connected in this circuit board up top are the 4 flex sensors as well as these 2 ultrasonic sensors. And then those are essentially sent down to the main board where there's some voltage divider action going on to use those flex sensors, as well as the integrated circuit that's dealing with the ultrasonic sensor, I believe, and sending this data off in a way that can be recognized by the controller. So what I want to do is something fairly simple, which is use the 4 flex sensors. And so I started mapping out with the back palm open and a multimeter in continuity mode. I started mapping out which of these pins, and it's essentially these along these edges here, are the 4 flex sensors, so that I can then solder some wires between those and a feather sense, NRF 52840. So the feather sense, I have one here. I'm actually running it on a screw shield feather wing, terminal block feather wing, so that I'll be able to, at least during testing and maybe in the ultimate package, have those wires going into these terminal blocks to the pins that I want to read them on the feather sense. The reason that I'm using the feather sense is that it has an accelerometer built on that I want to use, and it's got a NRF 52840 chip on it which does Bluetooth low energy. All of this is leading up to the fact that we now have a Bluetooth LE MIDI library for CircuitPython, which means I will be able to send data from the Feather Sense over Bluetooth, over the air wirelessly, to any synthesizer that can accept a Bluetooth LE MIDI input. And that MIDI is used to do things like turn notes on and off with different amounts of velocity, so how hard you're pressing a key. It can do things like send program changes, which is changing which synthesizer sound bank or preset you're using. And it can, the main thing I want to deal with right now is continuous controller changes, sometimes called CC. CC are all the knobs and sliders on any synth represented as a value from 0 to 127, and these are used for changing things like the frequency of a filter cutoff or the amount of resonance on a filter, the attack or decay, sustain, release on an envelope, so what the sound builds and fades off like. So it's pretty exciting to be able to even just use something as simple as the 4 flex sensors and the accelerometer that's built on here to send CC. So what I wanted to do is show you a little demo that I've started putting together. And first of all, I want to show you an incredibly lucky happenstance, which is when the Power Glove is put back together, I will probably have wires running just from this board up into this little section here, and check out what a great fit one of these is. It's kind of perfect. I've got an on-off switch here that I've got to deal with a little bit, but other than that, I should be able to put my feather and this board for connection, as well as a little battery under here, right into my wrist section of the Power Glove, And I might cover it with some fabric or something with a little flap so I don't get sweat on it or anything like that. So that's one thing that I was really excited about, is that this whole thing is going to fit really nicely in this otherwise empty space. I don't know what that space was all about, but there it is, so I'm going to use it. And so what I have, besides a lot of screws that I know I'm going to lose, what I have for a demo right now is on my feather with the terminal block feather wing, I've got a couple of flex sensors, standard ones that we sell in the Adafruit store, plugged into it right now as voltage dividers so that I can test things out before I go and tap into the one on the power glove, and so that I could demonstrate something and write some code for it. So the way these work is that the resistance increases as the sensor bends. And there are two terminals coming off of it, so I've got, for each of those, one leg going to voltage and the other going through a voltage dividing resistor to ground. So it goes straight to one of the analog read pins, in this case analog 0. And then through a resistor it goes to ground, so it's acting as a pull-down resistor. And this allows us to get a nice analog read of these sensors bending. So if we take a look at how this will work in practice, what I'll do is open up this is a MIDI utility program called MIDI Wrench. And by connecting to Bluetooth LE with this guy right here turned on, you can see that I have some control change values flowing through here pretty rapidly. And so I'm sending the accelerometer values, and this will be really impossible for you to see probably on screen, but there's one value that's going from 127 when it's flat to 0 when it tilts sideways, and same in the other direction. And then same here, I have some that are starting at 127 and going down to 0, and one that's starting at 0 and going up. So you can kind of map these in software in different ways. And then what I'll do is, for a demo, this is going to port those MIDI signals. This is really good for bringing in the Bluetooth MIDI, and then I'm going to port it over to some synthesizer software. So iOS, this is AudioKit Synth 1, and I think it might be available also on Android. So this is a great synthesizer, and it allows me to map MIDI controls by using a MIDI learn function. Some of them are built in. There's some standard ones, like 74 usually does filter cutoff frequency. So what you'll see is, if I move these bend sensors, you'll see some knobs twirling. So there's one here on the left, pay attention to. As this bends, I'm changing a little semitone value for the main oscillator, so that'll change the pitch. As I flex this one, you'll see the large frequency knob and also the mod wheel. These are tied to each other on this software. So you'll see those things changing. And then if you look at this little resonance knob, it's going to change as I twist side to side. So what I'll do, so you can actually hear that, is I'm going to put this keyboard here into hold mode. Let me just hold a note. So hopefully you get the idea. That's not the most musical example in the world. But my idea here is that I'll be able to have these bend sensors that are in the glove controlled as I bend. And I'm going to try to use the original ones. They should be in good shape. We'll find out. I haven't tested them properly. But if not, I will slide in some replacement ones that we have. But it would be great to use the originals. And so that is the plan. Now, what I wanted to do is check and see, first of all, if there's any questions. And then second of all, I wanted to show you how the software that I'm using right now is working so far. So I'm going to bring my controller over to my workstation here. Let's check in with Discord. First of all, how's the sound? I just want to make sure there's no sound errors happening. Oh, someone asked how hard, yeah, Wolf220 asked, how hard would it be to fit all this stuff in the glove? Yeah, apparently it's going to be really, really easy, which I'm excited about. Oh, good, no delay. I'm glad to hear that. Thank you. Why are flex sensors so expensive, asks Wolf220. I do not know. I mean, maybe the manufacturing process is labor intensive or the materials are expensive. I'm not really sure. All right, good. We have a good sound check. I'm glad for that. So let's take a look now at how this works in code. Let's open up Moo. And let me go to a small screen me and a big screen of Moo. A little me over there. So let's go up to the top of this. What the key things going on are, I won't go through every detail of this, but some of the key things that are going on is that I'm importing the Adafruit BLE library, this new Adafruit BLE MIDI library that Scott Tan-Newt has been working on. So direct questions at him if you have some specific ones, as well as Adafruit MIDI. And then some of our standard BLE stuff for advertising, because this is a device that will advertise, or a peripheral that will advertise itself as having this BLE MIDI capability. And then from the Adafruit MIDI, we're bringing in a few of these MIDI message types that I want to use. Control change, note off, note on, and pitch bend. And I'm not actually using pitch bend right now, but that one's interesting because it's actually 12-bit, so we can use much finer grained resolution if we want to from one of those bend sensors. And you can see I'm bringing in the Adafruit LSM6DS accelerometer, which is the one built right onto the board, right onto the Feather Sense. And then I have a couple more libraries I need for analog and also simple I/O, so I can do some remapping of values. I set up the accelerometer, and then here you can see I'm instantiating a couple of the board analog read pins with some convenient names. So analog in thumb, analog in index, and you can see I'll be able to do middle and ring as well. Interestingly, on the Power Glove PCB that's in the palm section, those are marked as for thumb, index, middle, and ring with the first letter of the words. So that it made it pretty easy to tell which wires were which. We're then creating the Bluetooth radio, instantiating that as BLE, checking for a connection, and I'm also creating the MIDI service here that's going out on, which I think this goes to MIDI channel 1 when it says 0. We have an index of 0 on that. And then I'm setting up my little function here for dealing with reading the flex sensors. So when we use this later, what I do is I have this function called getFlexCC, and the inputs to it are sensor, so which one am I trying to ask for, and then the values need to be remapped because they're actually 16-bit analog read values, so it goes from 0 to 65,000 something. So what I do is I give it the range that I'm finding on the sensor just by printing the value and checking it, and each of them might be different. So this allows me when I call it to say what range I want to use of the analog sensor, and this would be the same for anything that's an analog sensor, such as a potentiometer. I now am grabbing the raw flex value from this sensor.value read, so that's reading the analog pin, and I have this nice variable now that I can refer to. And then I'm setting up the flex CC, or control change, as a remap. So that's this simple I/O. In fact, let me zoom this up. You can see this better if I zoom in. That's this simple I/O function called map range, and that allows me to input the starting value, which is this flex raw, so that might be 17,000. Or sorry, that flex raw is the value we're getting, the pin we're reading's value. Then low in, I'm saying might be 0, and then high end might be 65,000. In an ideal world, that's not at all what I'm seeing. I'm seeing like 8,000 to 12,000 or something like that. And then I'm remapping it to 0 to 127, so that gives me that little range that the MIDI CC is expecting. Then I also have to turn that into an integer, because this will return a float for me. So I just take that same variable and I run it through this int function, and now I get whole numbers. And then I return whatever that final number is out of this function. So when we call this function, what we're just going to get back is a number. Then up here is a bunch of stuff I commented out that I was testing, but we'll look at a version of that a little lower that I have kept. And then, hey Scott, you're over on YouTube. Hello, I just saw you pop up. The connection is made here, and once we're connected, I'm doing a few things. One, I haven't neatened this up. This is mostly code I wrote this morning and last night, so some of it I will neaten up into other functions probably. But if you look, let me see if I can make this a little wider for you. Hold on one second. No, that's just making it bigger in general. If you look at this Excel data, that's a variable I'm grabbing by reading the accelerometer acceleration. And then from that we get a tuple, so we get the x, y, and z axis values. And so what I do is in this case I'm just reading z, so that would, the way this is going to be oriented, that would be just rolling my arm to change that. So you'd be able to use your fingers to send some things and roll your arm to do others. So I'm just asking for z here by saying Excel z is the third item in this list or tuple that comes back. And then I'm creating, similarly to what I showed you before, to remap, I create a CC for z, that's the accelerometer z, that is a remap of the range of whatever we get from 0 to 10, remap to 0 to 127. And then I turn it into a whole number, integer, with this. And then finally, I'm sending that using the BLE MIDI. So this MIDI.send control change, and this is the control change channel that I'm sending it over. So is it channel or number? I can't remember. But control change 73 is often the attack envelope is the attack of an envelope of how a sound comes. So if you have a large number for the attack, it's going to softly fade into the sound. If you have a very low number, it'll be a sudden strike type of sound, percussive. And I'm sending to that MIDI CC this value, whatever we read from the accelerometer, so 0 to 127. And then here you can see that now I'm using the function I created called getFlexCC that we created earlier. And so for the thumb CC, I call that getFlex function, but I tell it to grab whatever the analog in thumb value is, so that's the reading on pin A0. And then here you can see my range. I'm saying the range there is actually kind of flopped upside down. I'm sending a range of 16,000 to 8,000, and I think that's maybe because that flex sensor was manufactured opposite of the other one I was using. I didn't pay attention, and it actually is oriented differently for what I would consider my power versus my signal and ground with resistor for the voltage divider. But it's easy to flip that around in math, so that's what I've done. And then here, just for reading it out, I'm printing that value. In fact, let me plug it in right now so you can see that in action. And what I found is that this stuff it's quite necessary to print these to the REPL in order to know what the heck is going on. So right now in the mode it's in, it actually needs to connect to Bluetooth before it'll show me anything. So that's what I've just done. And let's unplug my camera switcher, because that's always the first serial device. That bites me every time. There we go. So this might be hard to read. I can probably zoom in here a bit. I don't think I can expand that much taller, unfortunately. It's not letting me expand it at all. But what you'll see here are values like 127, if you see that showing up there. If I bend one of these bend sensors, you'll see they're both at 0 now, and there's one of them changing. I don't know what that 509 is. Scott probably does. And I don't think I'm sending out, am I sending out the accelerometer? Yeah, I'm sending that to. So I had to trim out some of this stuff so I actually could see what was going on and put in sort of longer delays in there earlier. But that's how I figured out the ranges, was just by printing out the voltages as they were coming through from the analog read. Let me close that. So then we send the control change to 74 for whatever the thumb is, and that's my filter sweep frequency, cutoff frequency. And the question TrueTech says, what's the baud rate? MIDI is at like 31,300 or something like that. I think that's the baud rate. So it's not super fast, but it's good enough for this kind of stuff. Oh, right. Yes. So Scott, no baud rate because it's over BLE. Yeah. So the question is more, what's the latency? And I don't know. I haven't tested it, but for this kind of stuff, I'm not going to notice any latency on doing these effects kinds of things. You'd be much more likely to notice it if you were trying to send note-on messages and play the thing. Yeah, so Scott said the BLE does a connection event every 11.25 milliseconds or so. The other interesting thing, and I haven't done this yet here just because I was in testing mode, is that I believe these can be sent as a single MIDI send. So we can send a list. So this control change, I can put this in another set of parentheses and brackets, and then send in one message all of those. I believe that would help a lot to get the any kind of latency out of the system if we're sending a lot of values. Again, I don't sense any right now with what I'm doing. So that is the thrust of how this is working. We're just about out of time, but let me go back to the downshooter for one more demo of how this is working. So I'm going to unplug. I really should plug a battery into this so it doesn't keep dropping. If we head over here, and I think given the space I have in the power glove, I'll be able to put one of the little, I think it's 400 milliamp hour, 450 that we have that fits right under a feather. That'll work really well. By the way, this is the first thing I tested was a Itsy Bitsy NRF 52840. Also works great, just didn't have the accelerometer on it, but you could get pretty small devices that'll do that BLE MIDI. Okay, so what you'll see is that this software is going to detect my CircuitPython. It doesn't want to focus. This blurry text here is my CircuitPython device, and it's saying I see a thing that's got BLE MIDI, but it's not connected. So we'll tap on it, and it'll make the connection, and then you can see the values start flowing. Let's try to see if we can go to a nicer sounding wave here. I got to remember if I have. Yeah, it's pretty basic sounding. That'll work. And I'll zoom out even a little more. And just, even though it's not really the one hooked up in there, so that we can have the somewhat full effect of how that's going to work, I'll put a flex sensor in the glove here. And these are, turn that down a little. These are, you can see them in here, they're just underneath this half glove. So I'll put this one in. Side of here. That's a fun sound. Let's put this back on. Turn that volume back up. And then if this were in my wrist, tilting it, changes that resonance. And where's that other sensor? I've lost, there's one. That one just does chaos right now because it changes those semitone values. All right. By the way, that's a free app that I'm running. It's awesome. It's called Audio Kit Synth 1. I believe we also still have a free version of the Moog, Mini Moog available online. It might let me switch this one to MIDI, Bluetooth. Try it. Yeah, so, sorry I took off the glove. Why did I take off the glove? You should never take off the power glove. All right. All right, so again, not super musical example, sorry for that, but a lot of exciting promise there, and I'm going to try to incorporate some of the other features of the Power Glove at some point. The buttons on there are really tempting. I know that can be a lot trickier than tapping into these flex sensors, but I may give that a shot as well at some point. But the first version of this, I'm going to try to keep it simple, get a clean integration in there, do kind of as little damage to the Power Glove as possible, and then we'll take it from there. So thank you so much for stopping by. Before I go, I will remind you that we're going to have a very special show and tell here in just about a half hour or so. So I will put the link into the Discord, and there's also a blog post up about it that'll send you a link to get to that Discord if you don't know where that is. And then we'll have a half hour for people to come on and show some cool projects they're working on, projects they've completed, that they're about to start, that they may one day start, and they have some cool parts laying around to show off. Anything is game, so please come on. And we can show each other what we're working on. So let me, before I go, check in on the Discord chat and the YouTube chat. Sorry, Facebook, you never emerged today. Let's see. Oh yeah, Janiscu says perhaps Naomi and Pedro designed Power Glove for 3D printing with buttons. Yeah, there's a lot of possibilities there. I got this one pretty cheap, I think. Less than $50. I've heard stories of people getting them for free back in the 90s by just asking Mattel for them when they stopped selling them. Yeah, air guitar with the glove would be cool. I like that idea. All right. Well, thank you all so much for stopping by, and please, I encourage you to come on over to the show and tell in just a little bit. For Adafruit Industries, I'm John Park. This has been John Park's Workshop. See you next time.